In this video, we're going to be looking at finding the probability of compound events. In particular, this one, we're just going to be looking at disjoint events. And so if you see in this bubble up here, it says if A and B are any two events, then the probability of A or B is probability of A plus probability of B minus probability of A and B. However, if A and B are disjoint events, then the probability of A or B is just equal to probability of A plus probability of B. And that's because that intersection is empty. And so probability of A and B when A and B are disjoint is just going to equal to 0. And so that's why it's not added on there. You could still add it there or subtract it, but it's just going to be a minus 0. So let's look at some examples of those. So remember, for these disjoint events, it's just going to be equal to probability of A plus probability of B. So these first two examples says events A and B are disjoint, find probability of A or B. Well, I know probability of A or B is just going to be equal to probability of A plus probability of B. So I get 0.35 plus 0.12, which is going to equal 0.47. Okay, next one, I have that the probability of A is equal to 0.07 and probability B is 0.65. So that means that probability of A or B is just going to equal to the probability of A plus probability of B. So I get 0.07 plus 0.65, which is equal to 0.72. Okay, now let's look at some real-world examples. So number 3 says a card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face card? Well, here I need to first determine whether it's disjoint or overlapping. I know these are given as disjoint, but when you get to your homework, you're going to have to determine whether these are disjoint or overlapping. Well, I know with a deck of cards, a 10 is never going to be a face card because a face card is the king, queen, or jack. So that means that these are disjoint events. So that means that the probability of 10 or a face card, which I'm just going to label these events as A and B. So I'm going to say A is equal to 10, B is equal to a face card. So probability of A or B is going to equal to the probability of A plus the probability of B. So I need to find the different probabilities for either drawing a 10 or drawing a face card. Well, a standard deck of cards has 52, so these are both going to be out of 52. And I need to determine how many of each type of card there are. Well, for a 10, I know there's 4 suits. There's the spade, heart, diamond, and club. So that means there's going to be 4 different 10s. And then a face card, I know there's 3 different types of face cards. There's the king, there's a queen, and there's a jack. And there's going to be 4 of each of those for the 4 suits. So that means there's going to be a total of 12 face cards. And so when I add those together, I get 16 over 52. And when you divide that, you get approximately 0.308. Okay, let's look at one more. Here it says a bag contains 3 red marbles, 8 blue marbles, and 6 green marbles. What is the probability that you randomly select a blue or red marble? So here I already know this is disjoint because there's no way that you're going to be pulling out a blue and red marble because that doesn't exist. There's only the blue and red. They're separate. So I know that's going to be disjoint. And so I'm going to have event A be selecting blue, and event B equals selecting red. So that means that probability of A or B is equal to the probability of A plus probability of B. So I need to figure out the different probabilities for drawing these. Well, I see for blue, there are a total of 8 blue marbles. And I need to divide that by the total number of marbles. Well, the total number of marbles are 3 plus 8, which is 11, plus 6, which is 17. And then for red, I see that there are 3 red marbles, so this is going to be plus 3 out of 17. Well, when I add those, I get 11 over 17. And when I divide 11 by 17, I get approximately 0.647.